Hello, welcome back to our chemistry class. Today we are going to talk about the second part of preparations of alcohols. In our previous lesson, we have studied preparation methods like preparation of alcohols from alkyl halides by substitution reactions, preparation of alcohols from alkenes by addition reactions, preparation of alcohols from alkenes by hydrobolation oxidation, preparation of alcohols from esters by hydrolysis reactions, and preparation of alcohols from carbonyl compounds by reduction reactions. And today we are going to continue with other various methods. I call all of you to stay with me and learn together. The very first reaction of preparations of alcohols is from Grignard reagent and an epoxide. When an epoxide reacts with the Grignard reagent and then hydrolyzes in acidic medium, an alcohol is produced. Here is a general equation where this is an epoxide, which is a cyclic ether, and an organomagnesium or Grignard reagent. First of all, the bond between carbon and magnesium of organomagnesium is broken, and a pair of electrons is shared with electron deficient carbon of the cyclic ether, which repels electrons of the bond between carbon and oxygen, and this produces an alkoxide. This alkoxide with the magnesium halide forms a magnesium alkoxyhalide, which is a transition molecule and is unstable. The transition molecule which is formed is then hydrolyzed by water in acidic medium, where oxygen donates electron to the hydrogen of water molecule, and water is deprotonated to produce an alcohol and magnesium hydroxyhalide. Here we have an example when this simplest epoxide, which is called ethylene oxide, reacts with organomagnesium. It will first give a transition molecule which is magnesium alkoxychloride, and this is hydrolyzed in acidic medium to produce an alcohol and magnesium hydroxychloride. The next preparation is the preparation of alcohols from Grignard reagent on carbonyl compounds. All the three types of monohydraulic alcohols, primary, secondary, and tertiary alcohols, are obtained by the use of Grignard reagents and carbonyl compounds. This is done by addition of organomagnesium on carbonyl compounds followed by hydrolysis to yield alcohols. The general equation is this. Here we have a carbonyl compound, which may be an aldehyde or a ketone. If this R is hydrogen, then this is an aldehyde, but if the R's are all alkyl groups, this is a ketone. And here it is an organomagnesium. As we saw it in a previous reaction, the bond between magnesium and the carbon in organomagnesium breaks, and the electrons are donated to electron deficient of carbonyl compound, which will break this pi bond to produce a transition molecule like the one we saw in the previous example. This transition molecule is then hydrolyzed in acidic medium to produce an alcohol. Here we have an example. This is a ketone which is called acetone reacting with organomagnesium, which is then going to produce a transition oxide of magnesium bromide that will again react with water in acidic medium to produce an alcohol. To explain this, when we use a ketone, we always produce a tertiary alcohol like this one. If you want to produce other classes of alcohols like primary and secondary, you use aldehyde. And the primary alcohols are produced by the simplest aldehyde, which is called formaldehyde. The rest of aldehydes produce secondary alcohols. Let us look at the third method of preparation of alcohols. The third method of preparation of alcohols is from fermentation processing. What is fermentation? Fermentation is the slow decomposition of complex organic compounds into simpler organic compounds by the activity of enzymes. And what are enzymes? Enzymes are complex nitrogenous or proteins, non-living macromolecules of high molecular weight derived from living organisms. That's why they are called biological catalysts. Every fermentation is characterized by evolution of gases like carbon dioxide or methane, and they are always exothermic reactions. Here we have two types of fermentation: fermentation from sugarcane and fermentation from starch, which are all the methods we can use to produce alcohols. And the alcohol we produce mainly in this fermentation process is ethanol. Let us start from the fermentation from sugarcane. The whole process goes like this. When sucrose is crystallized from concentrated sugarcane juice, dark brown colored mother liquor is left, which is called molasses. It is diluted with water, acidified with dilute sulfuric acid, and then ammonium sulfate is added. Then yeast is added and the temperature is kept at 30 degrees for 2 or 3 days. Ethanol is formed by fermentation, and the contents are filtered and the filtrate is distilled. Molasses is diluted in order to favor the growth of microorganisms, and sulfuric acid is added to acidify the medium because it favors the growth of microorganisms and inhibit the growth of unnecessary ones. The ammonium sulfate is added to add nitrogen in the mixture because it's the food for microorganisms. Temperature must be kept at 30 degrees because if it goes beyond, now the microorganisms will die. The contents will be filtered and distilled because when you do fermentation, you get ethanol which is mixed with the many other components, water and others. So to get ethanol only, you have to separate starting from filtration and then distillation. So let us look at the chemistry behind this process. An enzyme of yeast called sucrase catalyzes the hydrolysis of sucrose to glucose and fructose. Here we have a molecule of sucrose, which is the sugar in sugarcane, reacting with water under the activity of enzyme sucrase. And this one gives two types of sugars, glucose and fructose. They have the same structure. They have the same molecular formula, but different structures. Then another enzyme of yeast called zymase catalyzes the decomposition of glucose or fructose to ethanol. Here we have one of them, glucose or fructose, which is then decomposed by zymase, which is an enzyme, to give ethanol, which is our main product, and carbon dioxide, which is the side product. The second method is from starch. The general process goes like this. Starch containing agricultural products are grinded and made starch slurry or gelatinized with water for enzymatic hydrolysis. The starch slurry is cooked and liquefied by alpha amylase or liquefying enzymes at around 95 degrees centigrade and a pH of 6 for 2 or 3 hours. The liquefied slurry thus obtained is subjected for further hydrolysis to glucose by saccharifying enzymes, which are called glycoamylase, at lower temperature between 40 to 60 degrees centigrade with the pH of 4 to 4.5 for 6 hours. The glucose syrup thus obtained is then fermented using yeast at about 30 degrees centigrade with a slightly acidic medium for 48 hours. The fermentation broth is then distilled at 75 degrees centigrade to recover ethanol of 95% purity. The total time required for conversion of starch to ethanol in the fermentation broth in the conversion process is around 3 days. Let us look at the chemistry behind this process. First of all, malt obtained from sorghum grains, maize, cassava, millet, and so on, contains an enzyme called diastase, which catalyzes the hydrolysis of starch into maltose. And what is malt? Malt is a germinated grain which is then dried in the process called malting. For example, if you have ever read the advertisement panel for Skol, you have seen that 100% malt, which means that the main raw material they use to make Skol beer is malt. And then the equation goes like this. We have starch, which is a long-chain sugar molecule. It is called a natural polymer, which is then broken down using water under diastase activities to give simpler sugar, which is called maltose. At room temperature, yeast is added and one of its enzymes called maltase catalyzes the hydrolysis of maltose into simpler sugar called glucose. The equation goes like this. Maltose reacts again with water. The hydrolysis process takes place under maltase enzyme to give the simplest sugar, which will be glucose. And then glucose is catalyzed by zymase to be decomposed into ethanol and carbon dioxide. Here we have a glucose. Under zymase activity, it gives ethanol and carbon dioxide. And here the carbon dioxide is the side product of this process, where ethanol is the main product. But again, all these ones are in a liquid mixture, which is called beer. Remember, our target was to produce ethanol, not beer. But the first process will produce ethanol and the other mixture components, where the whole mixture is called beer. This is the process which is applied in local villages. Our parents, our grandparents are doing the similar process without knowing that they are applying chemistry. For example, in our villages, there are local beers like urwagwa or ichigaji, which are the products of the process of fermentation, where they use, for example, sorghum grains for ichigaji and the banana for urwagwa. What they do, the whole process is similar to this fermentation process we are talking about. But the people there who are very, very smart in chemistry, they don't know that they are using that chemistry. Note, the ethanol obtained by the fermentation process is only about 11 to 18%, which means that it's a beer, not yet ethanol, and our objective is to produce a pure ethanol. So this is made concentrated by distillation, which converts it to about 95% ethanol, meaning that to get ethanol, fermentation is done, but you have also to do distillation. But because we learned that ethanol is making azeotropic mixture with water, the distillation cannot separate completely ethanol and water. That's why you can see that we can always get the 95% of ethanol and the 5% will be water. How will you get now 100% ethanol? You have to apply the following method. Either you can do distillation with benzene as a third component, you add it in the mixture, or you add quicklime, calcium oxide to remove water, because this is a dehydrating agent. For these other methods, you are going to do research and find out what are these reactions, what are the reagents, and what are the conditions of reactions, and what are the products of the reactions. First reaction is the action of dilute potassium permanganate on alkenes allows us to produce diol through cis-hydroxylation. Second is oxymercuration and demercuration of alkenes. And the third is preparation of alcohols from primary amine. Thank you so much for your kind attention, and I welcome you all for the next lesson.